Thank you for joining us today for our webinar, Gigabit LTE Deployments, Setting the Stage for 5G. I'm Sean Kinney, Editor-in-Chief of RCR Wireless News and our companion site, Enterprise IoT Insights. To set the stage a little bit, 2017 was a big year for Gigabit LTE in terms of trial activity and commercial deployments, and 2018 promises more of the same as service providers lay the groundwork for rapid commercialization of 5G. This continued evolution of LTE to LTE Advanced Pro features provides a big boost in capacity to users, but also has big implications for the entire telecommunications industry in terms of devices, spectrum, network infrastructure investments, service assurance, test and measurement, and more. Today, we've got a great group of panelists that are going to share their perspective on the topic. By way of housekeeping, we will make copies of these slides available following the webinar, and a recording of the session will be available on YouTube. The webinar also has an accompanying report that takes a deeper dive into the subject, and that will be distributed in the coming days. In terms of Q&A, we've got time set aside following the presentations to answer your questions, which you can submit throughout the session using the Zoom portal. Now I'd like to introduce our panelists. To provide an analyst perspective on Gigabit LTE, we've got Rehbehn, founder and principal analyst of CritComm Insights. From Qualcomm Technologies, we're joined by Matt Branda, director of technical marketing for 5G. Ian Gresham, technology fellow with Anokiwave, is with us today, as is Kasshif Hussain, solutions marketing lead with Viavi Solutions. So thank you all for joining the discussion. To provide a little more context on Gigabit LTE, there are four primary building blocks that you're going to hear a lot more about in the coming hour. Those are 4x4 MIMO, 256 QAM, which enables more data per bit to be transmitted. Then there's multi-channel carrier aggregation, which joins different bits of spectrum together into a larger data pipe. Then you have license-assisted access, which allows for aggregation of licensed and unlicensed spectrum. I mentioned that we've seen strong carrier adoption of Gigabit LTE in 2017, and I wanted to provide a quick snapshot of activity that's just going on here in the United States. Verizon's made Gigabit LTE available in more than 560 markets and is planning a nationwide deployment of LAA based on some impressive trial work that resulted in more than 900 megabytes per second in the downlink. They're also testing massive MIMO for future deployment. AT&T calls their gigabit service 5G Evolution, and that's live in around 23 markets, including Indianapolis, Indiana, where they've also deployed LAA-compatible small cells. T-Mobile has full Gigabit LTE available in around 430 markets, and at least one of the three components in an additional 490 markets, which forestalls their plans to broaden the availability of that service. T-Mobile is also planning a major deployment of small cells this year, including LAA-compatible small cells. Sprint has 3-channel carrier aggregation available in around 100 US markets, and they're using that to tap into their 2.5 gigahertz spectrum holdings. Based on some of the commentary provided at the end of the year by their CTO, Sprint's going to supplement their carrier aggregation this year with 256 QAM and 4x4 MIMO, as well as higher order MIMO, which they've been testing out with Samsung. So with that, I'm going to turn it over to Rehbehn, founder and principal analyst of CritComm Insights.
Thanks, Sean. It's great to join this august panel of experts talking about a very important subject. The topic of Gigabit LTE has profound implications for the ecosystem that supports the wireless industry, the device suppliers, the silicon suppliers, as well as the service providers, as you can see from Sean's rundown of the aggressive steps that are being taken across the United States by the major service providers. But this also has very, very important implications for the enterprise and consumers as well. We have wireless generations generally changing every 10 years, and we're certainly well into the shift from 4G to 5G. But LTE is special. If you could advance the slide, that would be lovely. And one more. Thank you. So LTE is special. The E in LTE does stand for evolution. And the technology experts continue to refine the LTE capabilities in parallel with dramatic advancements that are occurring in the 5G technology. Gigabit LTE is an example of that, as Sean was describing with some of the key features. It is a vital technology upgrade that will have an impact on the spectrum efficiency, the speeds that are experienced by users, and the cell edge performance. Advance the slide, please. So why does this matter? Well, it comes down to three general chunks. The economics. Basically, we have end user activity embracing significant amounts of video transmission. This has an impact on the operations of the network, the economics behind the network. Gigabit LTE can help address this. Secondly, the customer experience. What joy and what pleasure do consumers get from their wireless experience as they're moving about in the wider world? In addition, from the enterprise point of view, what interesting business cases get unlocked as we remove barriers to performance? And removing barriers is what Gigabit LTE is all about. And then finally, we're at the dawn of 5G. The progress on 5G is dramatic and rapid, but it will enter the market not as a ubiquitous deployment, but as focused deployments in hotspot areas initially. And Gigabit LTE will be the essential mechanism that binds together the user experience. Next slide, please. So let's take a look at the economics. What's happening here from the viewpoint of a service provider or a mobile operator? Mechanisms such as the 256 QAM, QAM enhancements, they help drive down the cost per bit per hertz for supporting the user traffic. And in an era of sharply increasing video traffic, as well as new applications that come on with augmented reality, this matters. This has an impact on the network profitability going forward. Secondly, in the family of mechanisms that constitute Gigabit LTE, we have very flexible approaches for dealing with spectrum that is not licensed through an auction process for a service provider. So with license-assisted access, we have now the possibility of augmenting our licensed spectrum with unlicensed band capability to sharply increase the amount of bandwidth that's available. Likewise, in the United States, we're very fortunate to have a very flexible regulatory regime around the 3.5 gigahertz spectrum, a very clever sharing mechanism with the federal government, and a CBRS class of service now starting to get out into becoming a reality. Still in early days, but it points to the flexibility that will then flow into enabling Gigabit LTE, but without astronomical spectrum acquisition costs. And then finally, as you have Gigabit LTE class capabilities coming to roost at a cell site, particularly close into the cell site where you get the maximum modulation capabilities, we have user equipment as it enters in with that capability, taking advantage of these very efficient mechanisms. Well, that relieves pressure on the network through that efficiency. And so even older devices that are being operated in the cell site will benefit from the gigabit class capabilities, even though those older devices are not necessarily getting gigabit service. The efficiency of the cell site as a whole will improve. And so this has broad impact on the service provider economics by allowing, in some cases, the ability to defer CapEx, even if it's for a small amount of time. That can have a meaningful impact on the financial statement. Obviously, as you increase the end user experience and more traffic flows, there's a possibility for more revenue, so you maximize your revenue possibilities. And then Finally, operating cell sites cost money. And so as efficiencies are plumbed into the system, we have the ability to bring down OpEx that is recurring. Very important contributions. Could we fast go to the next slide, please? So let's talk about this from a customer service, customer experience point of view. You know, like it or not, speed is a benchmark. You know, to be sure, day to day, are we using a full blast of capacity, speed capacity that is on a cell sector? The answer is no. But the responsiveness of that site, the ability to get the bursts of data, minimize buffering time when you're starting a video, this then plays into the perception that the end user has of the service that they are paying significant amounts of money for on a monthly basis. By implementing techniques such as Gigabit class LTE and raising the bar in terms of how fast the traffic can go and how much performance there is that's open to the end users, we eliminate barriers. And now, let's take a case in point. A videographer is shooting a news segment. They can now perhaps upload more information over an air interface and perhaps do activities or delegate activities to entities that are in the cloud, colleagues that are not on site, change their way of operating. And that can bring some strong cost savings to business operations that wouldn't be possible otherwise without the innovations in Gigabit LTE. Let's go ahead and advance to the next slide. So I mentioned 5G. We have LTE continuing to evolve. At the same time, 5G is progressing rapidly. 5G will be very important for the brand integrity and reputation of service providers, but it will not be deployed throughout the entire network at first. It will probably be years before you have that situation. So Gigabit class LTE is the vital fluid that surrounds these islands of 5G to ensure a harmonious user experience, that consistency as end users move in and out of 5G footprints. We've learned the lessons from the old days of transitioning from 2G to 3G, 3G to 4G. Those have been difficult transitions, frequently where the end user experience is noticeably different when the end user is shifted down to an older technology. Gigabit class LTE will help smooth out these rough edges and provide an important foundation going forward for the service provider. With wireless service, consistency matters. If you go back to the 1990s, we were quite happy to have really horrid voice conversations. Scratchy, unintelligible, analog voice calls where the call would fade out and then fade back in as somebody went from site to site. But we accepted that. We were actually pretty tickled and happy to have that service because it was providing something we've never had before, the ability to talk when we were away from a wire. But it was consistent. We knew what we were getting. As networks get better, as the end user experience gets better, we get more demanding. We need the consistency. And providing the consistency of user experience between 4G and 5G is a very important function of Gigabit class LTE. Next slide, please. So the good news is that, as with all things wireless, the network equipment that is deployed in the field becomes available first. Device suppliers, I'm not talking about the innovators like Qualcomm that are working hard on silicon very early in the process, but the handset suppliers tend to wait until they see enough of a footprint out there with a network to justify the investment in handset portfolios. Well, the network equipment is ready for gigabit class LTE. I had the privilege of traveling to Telstra last January to see the launch of the Gigabit LTE network in Australia in the central business districts. Impressive. Telstra invested a lot of effort and money to make that possible in their network. In the year since, we've seen now very interesting modems come on the market for consumers, enterprises to take advantage of these capabilities. And as Sean was saying at the introduction, this is now spread across the networks in the United States. We'll see this more and more. A final point, the cell sites are ready for this as well. There has been a tremendous push to bring fiber to as many sites as possible so that that link back into the middle of the network is ready for the load that Gigabit LTE can bring. Gigabit LTE is ready for business. So to go into the details of this, let me turn this over to Matt, who will bring the expertise of Qualcomm.
Yeah, thank you for your presentation, Ken, and please join us with Matt Branda, who's the Director of Technical Marketing for 5G at Qualcomm.
All right, thanks, Sean, and thanks, Ken, for the introduction. I'm going to build on some of the concepts that Ken talked about in his section, provide a little bit more information on the global status of Gigabit LTE, and also talk a little bit more about the role it plays in 5G. We'll also provide a little bit of data. We've been at the forefront of Gigabit LTE since the first launch back in January, as Ken was alluding to. And we've gotten to see a lot of real-world testing, and I want to share a little bit of the data from that testing, both from a user experience and a network capacity perspective. So let's get started. Ken hit on this. I'll just echo on it real quickly. We definitely agree Gigabit LTE is going to play a role in the 5G mobile experience as 5G mobile networks start to get launched early next year. As Ken was saying, 5G coverage will not be everywhere day one. So network operators are going to leverage the Gigabit LTE coverage that they have to deliver users that a very seamless 5G experience leveraging Gigabit LTE as an anchor. Not only will that provide consistent data experience, it will also provide multi-services in that 5G world as we head towards it. Next slide. So I think Sean and Ken hit on this a little bit. The term Gigabit LTE gets used a lot, and obviously that's the faster speeds with peak rates now breaking through the gigabit per second barrier. One thing I wanted to emphasize up front is it's a lot more than just faster peak rates. Gigabit LTE raises, I like to say, raises the overall floor. We've seen average download speeds exceeding well over 100 megabits per second. And not many of our households are experiencing that types of speeds consistently. Beyond the faster speed, it also delivers the more performance throughout the network, whether it's indoors or in congested areas like airports. And finally, the higher network capacity and spectral efficiency improves speeds for users in the network, all users in the network, not just the Gigabit LTE users. And this really kind of helps operators in efficiently addressing and delivering unlimited data plans to consumers. Next slide. I think both Sean and Ken kind of introduced talked a lot about the domestic in the U.S., the momentum. But really, 2017 was the year of Gigabit LTE, and that's continuing into 2018. It started in January of 2017 in Australia, as Ken was saying, where along with Telstra, Ericsson, and Netgear, we marked the arrival of the world's first Gigabit LTE network and Gigabit LTE device. And if you fast forward to present day, there are now 45 operators in 26 different countries around the world, either deploying or trialing Gigabit LTE. And as Sean mentioned, that includes all 4 major US operators. This is coupled with an ever-growing list of Gigabit LTE devices, including over 10 Gigabit LTE premium smartphones that are now available. These are all powered by the Qualcomm Snapdragon mobile platform. Next slide. All right, so let's get in a little bit to the use cases and some of the real-world testing that we've done. By supporting fiber-like internet speeds wirelessly over LTE, Gigabit LTE is enabling many of the next generation applications that require both very fast and very reliable connectivity, such as immersive 360 video and virtual reality. Now that we have live Gigabit LTE networks in commercial devices, we're now able to conduct real-world user experience testing to see these next generation applications in action. We recently commissioned a study with Signals Research Group to compare Gigabit LTE smartphones versus older LTE phones, like a Cat 12 phone. And the results here show download speeds were well over 2.5x faster with the Gigabit LTE phone. So these faster speeds equate to higher quality, more immersive content, such as flawlessly streaming 3D VR sports and entertainment, which we recently demonstrated with NextVR at CES. Next slide. The benefits of Gigabit, one important point I wanted to get across is it's not just about those new, next generation, more demanding applications. The benefits of Gigabit LTE can also be seen in more everyday experiences like everyday video streaming. So the third-party testing we did also looked at that and comparing Gigabit LTE phones to Cat 12 phones for more everyday video streaming. What we saw was much less video freezes, much less video impairments, much less audio-video sync issues, where we're consistently throughout the testing we're seen on Gigabit LTE devices. There's much more information on this third-party testing that's available on our website if you're interested. Next slide. When it beyond kind of the smartphone and streaming video, when it comes to getting some work done, Gigabit LTE also delivers a much superior access to cloud storage with reduced wait times and increased productivity. We recently demonstrated this function at a T-Mobile Gigabit LTE event. We set up 2 laptops side by side, one tethered to Gigabit LTE phone, one tethered to a Cat 12 device. We then shared a Google Drive folder with those 2 laptops, and the attendees were blown away by how faster the Gigabit LTE connected laptop synchronized with the shared folder. This type of functionality opens up the door to new and expanding use cases for connected cloud computing as we move towards 5G. Next slide. Beyond the user experiences, as was kind of already alluded to, Gigabit LTE is also the cure for network congestion by really increasing the network capacity for operators and also the spectral efficiency. With unlimited data plans now becoming more of the norm, capacity needs to grow and needs to grow efficiently. As shown in this slide, Gigabit LTE devices use a fraction of the network resources compared to other LTE devices when executing the same application. This becomes especially true in challenging conditions like indoor use or hyperdense environments. From the operator's perspective, Gigabit LTE efficiency gains bring with it significantly more capacity, which improves speeds for all users, not just the ones with the latest devices. Next slide. Sean hit on the 4 major technology building blocks for enabling Gigabit LTE, and I think there's some more technical details on these in the next presentations. I did want to make a point on one of these, which is 4x4 MIMO. Gigabit LTE devices will have double the antennas of traditional regular LTE devices, which will double the number of spatial streams in a good signal conditions, which effectively doubles the data speeds. But there's another important aspect of 4x4 MIMO that often gets overlooked. In the good conditions, we use it for increasing the speed. In weaker signal conditions, when you're far away from the tower or maybe indoors, The two extra antennas can act as kind of additional ears, if you will, that help the Gigabit LTE devices lock onto a stronger, cleaner signal from the tower, thus boosting download speeds even in the worst conditions. Next slide. I hope shared some of the real tangible benefits that our first generation Gigabit LTE modem is bringing to users and networks today. But we are not stopping there. We've already demonstrated our second generation Gigabit LTE solution, capable of receiving up to 12 spatial streams of LTE data. That is our Snapdragon X20 LTE modem, which is the world's first modem to support 1.2 gigabits per second, which is a category 18 device. It supports both 5x carrier aggregation and LAA. And this is significant because beyond kind of going up to those 1.2 gigabits per second, it also allows a much larger set of operators to be able to launch Gigabit LTE services. So with the 5x CA and LAA support, the X20 can support Gigabit LTE services with as little as 10 megahertz of licensed spectrum. This will expand the global footprint for Gigabit LTE as we prepare for 5G NR commercial network and device launches starting early next year. Thank you.
All right, thank you very much for that presentation, Matt. And now I'd like to introduce Ian Gresham, who's a technology fellow for Anokiwave.
Thank you, Sean. Also the previous speakers. Good morning or good afternoon to the viewers. I'm going to change gears a little now and talk about a slightly different aspect of setting the stage for 5G, which is really an umbrella term for a much broader vision for the next incarnation of telecommunications, and usually encompasses three areas of increased network capability. So IoT, where we have billions of devices connected to the network, which are usually low data rate. Low latency connections for V2X and augmented and virtual reality applications. But as we're concentrating on today, the demand for greatly increased data and data throughput for enhanced mobile broadband and also fixed wireless access, which we've heard is both an evolution of LTE as it stands, but also extending functionality to the millimeter wave spectrum. As we'll see, one of the fundamental enabling technologies for this shift to millimeter wave means development and deployment of phased array or active antennas, as they're becoming broadly known, to overcome some of the challenges posed by the very high line of sight and non-line of sight propagation losses that we have. For those of you who don't know who Anokiwave is, just a very quick background overview. We're a fabless semiconductor company, and we've been developing technology for low-cost and commercial active antennas in millimeter wave spectrum for well over a decade now. We've done about 45 or so products, both private custom developments as well as our own commercially available parts, and that's to provide all of the behind the aperture electronics that are required for active antennas. So one of the facts that may not be widely appreciated is that the demands that we're seeing for technology now for telecommunications at millimeter wave have already been long established in aerospace and defense and both radar and secure communications, as well as in the SATCOM industry for increased data rates. So in parallel with the continued evolution and development of LTE and the sub-6 gigahertz platforms, there's this parallel activity to harness wider channel bandwidths at higher frequencies. And that's driven by the exponentially increasing demand for data that we're seeing, and obviously the increasingly saturated spectrum availability in the existing bands, despite the hugely impressive results that we've already seen. Next slide, please. So this slide shows the release of new spectrum for telecommunications and how it's changed the regulatory landscape in the last 18 months or so. If you look at the top half of the chart, the horizontal axis represents the frequency spectrum from approximately 1 to 90 gigahertz on a relative scale. And the orange or the light brown bars on the middle and right of the top figure show the approximately 11 gigahertz new spectrum released by the FCC for both licensed and non-licensed use. And although the precise frequency allocations vary across the globe, there's similar initiatives in Europe and Asia as well. Now, the picket fence of blue lines on the left shows the fragmented and composite spectrum that's available below 6 gigahertz. So the available scale of the relative spectrum is quite easy to see. Now, the red and green bars on the chart show the frequency allocations for the aerospace and defense and SATCOM applications. There's been significant development activities for active antennas in these frequency bands for well over a decade now, with tens of millions of dollars in investment to pioneer the electronics and manufacturing technology required to develop and drive down the cost of deployment. So the chart in the lower half of the slide is a snapshot of some of our product developments which have been supporting these advancements. As you can imagine, the proximity and in many cases overlapping of these spectral regions make it obvious that the same technical problems and therefore very similar technological solutions apply for both requirements. What this means is that we've experienced that the same design and manufacturing philosophy, as well as the base technologies that we've been developing for aerospace and defense and SATCOM, can be leveraged and used across the different market segments, especially for now 5G telecommunications. And that enables a high degree of reuse. And that's also enabled the platform type approach to accelerate the development of active antennas. Next slide, please. So the biggest change in radio architecture for millimeter wave deployment, at least from a hardware perspective, is the requirement for the use of an active antenna for the physical air interface. You know, the radio architecture in terms of the modem, baseband frequency conversion remains fundamentally the same, but the mechanism for the air interface is radically different, and it's often perceived as the principal challenge for the millimeter wave radio. So it's worthwhile just reviewing this for a few seconds. So briefly, why are millimeter wave active antennas critical for 5G? Well, active antennas offer multiple advantages. The most important consideration is the high path loss at millimeter wave, which is somewhere around 62 dB per meter at 28 gigahertz for line of sight propagation. So, you know, that increases dramatically for non-line of sight propagation. And that means the development of a robust link seems extremely challenging. Well, the reciprocal benefit is that the short wavelength, which is about 5.6 millimeters at 28 gigahertz, means that you can develop a large effective aperture in a very small area. So that means you can generate extremely high radiated power through construction in the far field. And conversely, at the receiver, the radio sensitivity can also be scaled by increasing aperture size to intercept that available plane wave. And because the antennas are active, you can change the direction of the beam very dynamically to serve multiple users. You can provide spatial orthogonality through adaptive beam forming or shaping, and you can rapidly change point in direction to adapt to changing propagation channels in dynamic environments. And then depending upon how you form the array, you can also form subarrays of radiating elements which can be used to provide the MIMO functionality with orthogonal data streams that we've heard is also applicable for increasing data throughput and providing some link robustness. And again, all of these issues have been commented that different market segments that we've been served and we propose can be addressed by a technology platform approach. Next slide, please. So what that means is that although millimeter wave active antennas are a new feature and requirement for telecommunications applications, Anokiwave, we believe that the development of these products for 5G is really just a process of industrialization, not one of invention. So our experience of supporting multiple customers and millimeter wave products for over 10 years now, means that we believe that the general technology path is clear and developments are probably progressing perhaps faster than expected. So for example, looking ahead to Mobile World Congress in Barcelona next month, we're going to have our active array technology used to enable over a double-digit number of customers with a similar number of millimeter wave active arrays, all three of the principal millimeter wave bands. So that's 26, 28, and 39 gigahertz. So from a hardware or air interface active antenna perspective, development of physical air interface for 5G millimeter wave networks is starting to get acceptance. And I think we're on the path for now rapidly accelerating performance and capability enhancements rather than just demonstration. No doubt there are still problems to be solved, especially around the problems of the issues of user mobility. How do you implement this functionality in the UE and understanding what levels of quality of service can be guaranteed, as well as economic and business cases for the complete rollout of a new network infrastructure. especially in terms of this challenge of reducing total cost of ownership and reducing delivery costs of the gigabyte of data to the user, and they still need to be addressed. But in terms of setting the stage for 5G, which is one of the focuses for today's discussion, especially from future millimeter wave radio rollouts, we think 2018 is already off to an exciting and very promising start. Thank you.
Thank you, Sean. So we just talked about Gigabit LTE from different perspective. What I'm going to share is a different lens, is from a perspective of performance management and validation. When customers are basically investing heavily in Gigabit LTE, they want to ensure that they're getting their money's worth, meaning the end users are getting the experience for which they have invested heavily, millions and hundreds of millions of dollars. Next slide, please. So the three key features that we will talk about for Gigabit LTE and how do we ensure the performance is what it is supposed to be, or how the network was designed to be. So let's go to the next slide. So the key fundamental is performing a signal analysis. Basically, the modulation quality is essential to ensure that the end user experience is good. So what does that mean? I mean, the whole purpose of base station demodulation performance validation is to ensure that the network is performing as designed, and to validate or verify that if there are any potential E node B or network impairments, can be identified quickly. Now for that, different type of measurements are taken, like EVM, which is your error vector magnitude, or time alignment errors in case of MIMO validation and things like that. So Viavi's base station analyzer has the signal analysis feature, which can help you do that. So if your constellation basically is it's working in a perfect environment, then you will see the signal quality better and the user experience better. Can you go to the next slide, please? So in the case of MIMO measurement, for example, what I'm showing on there are two slides, right? One is the EVM measurement that that I'm sharing here for the different antenna streams that we were just talking about. So in the case of MIMO, how do you validate that my MIMO is truly working as designed and I'm getting the true benefit out of MIMO? So in that case, using a signal analysis function of a base station analyzer, you can look at the different antenna streams and basically validate. For example, in this case, I'm looking at the reference signal and also at looking at the constellation. You can see the constellation diagrams that, it is quite far away from the ideal constellation the way it should be. And you can see that in this case, you will not be getting the true benefit. So this can be done through the signal analysis function of the base station analyzer. On the right-hand side, similar thing, but from a power perspective rather than the EVM that we were talking about. So you can also note, basically, the whole point is, one thing is, okay, so my performance is poor, but how do I troubleshoot it? It's like peeling an onion, right? So you go to the next layer, you go down to that, which antenna stream is not performing well. Now, what kind of a problem I can have? There can be multiple, different kind of impairments, right? It can be a baseband impairment, it can be a RF impairment. So that kind of analysis, you can then keep on peeling the onion and basically identify if there was an interference issue, it was a hardware issue, it can be something within the baseband and those kind of problems. And you can do that kind of analysis with a solution like this. Next slide, please. Similarly, for the carrier aggregation function, as we all understand, you can have an intraband or interband, or even in the intraband scenario, non-contiguous carriers, right? So below is an example from a spectrum analysis perspective, where you have 4 different carriers. The first one is basically for an intraband contiguous carrier. So you can do an analysis and see how basically the RF environment looks like. And on the right-hand side, from a modulation perspective, basically same carrier aggregation function, looking at the different antenna streams, you can perform that analysis and see if I have a problem with one of those channels, what have you. Next slide, please. In this case, when we were talking about the licensed assisted access. Similarly, you can also validate the performance of your Wi-Fi spectrum as well. So on the left-hand side, doing the same spectrum analysis, and for problems like which are more, in a sense, not consistent. So, I mean, then in that case, you can also look at basically the dual spectrogram, and you can validate the performance of your RF spectrum in that case. And you can actually look at them, both of them together, so it will give you a much better view of how my RF spectrum looks like and if there are any challenges or what have you. Next slide, please. Same thing from a signal analysis perspective and identifying any interference issues, because if the objective is to offer the best quality of service, you would like to make sure if there are any interference issues, you can eliminate them, identify them, right? And so this solution will actually help you in getting there. Next slide, please. And similarly for the last features of the Gigabit LTE, the 256 QAM, where what we are looking at is the constellation diagrams to get a better view, and also the different measurements I talked about, like the EVM and frequency error, what have you, and also the timing error. So in that case, with the help of this solution, you can identify whether you're getting the right modulation scheme in the perfect RF environment, or if your RF environment is poor, so you have been downgraded to maybe 16 QAM or something to that effect. So that kind of analysis you need to do as a service provider to ensure that your network is performing the way it is supposed to be and as per design. That's it. Thank you. Sean, I think you're on mute.
Ian, I wanted to explore further the topic with you of the mobilization of millimeter wave deployments. As you mentioned in your presentation, the attention right now is focused on this fixed wireless use case, and we've even seen operators like Verizon touting a commercial service around residential broadband based on fixed wireless and using millimeter wave spectrum. Can you tell us a little bit about some of the challenges you expect will be addressed as we turn from fixed to a mobility use case?
I think perhaps other people on the call might be better qualified than me to address that. But clearly the ability to generate multiple steerable beams from a base station or an access point kind of architecture is somewhat less restrictive than obviously the reciprocal connection from a UV and the both in terms of the available aperture size, but also in terms of the power resource needed to generate that AIRP, and the increased loss characteristics at millimeter wave that especially the human body generated in terms of a loss characteristic. Fortunately, I would expect that the downlink traffic is going to be significantly higher and more of a percentage of any communication than the uplink. So there may be some benefits there, and certainly some of the demonstrations that I've seen Qualcomm actually do at Mobile World Congress last year were very encouraging. But it's clearly a challenge. But I also know that many people are planning for UE implementations in mobile and portable devices in 2019 and 2020. So my understanding, at least from what's available in the open literature and what people are presenting at conferences and other such events, is that some very good progress is being made.
Yeah, Matt, perhaps you can weigh in on that. I know that Qualcomm has created a millimeter wave test device that's in a smartphone form factor. Can you tell us a little bit about that device and how something like that helps OEMs get a better grasp of how they should be designing devices and approaching the RF front end for millimeter wave? Matt, it looks like your line is muted, but we'll move on to a different question and perhaps circle back to that. Kasshif, we have a question here from Viavi relative to LTE Advanced License Assisted Access. Does Viavi have available today products that are compliant with those specifications? And if so, can you tell us a little bit about that?
Right. So when I mentioned the base station analyzer, so today we have a solution that you can use to validate your license assisted access. I mean, if you have already deployed, for example, let's say if you are a service provider and you are trying to take advantage of the unlicensed spectrum, then yes, definitely you can use our base station analyzer product, and using that you can do performance validation, and you can ensure whether, I mean, you are getting that true advantage. And I know there's some of the listen before connect kind of scenarios, and you can basically perform a true validation of your RF environment in that case. And if there are any interference problems, or you can see the channels that are busy or anything like that, you can do that kind of validation with our base station analyzer product with the signal analysis functions in it. So,
all right, thank you for that. And then we have Matt back on the line. We can circle back to the question regarding millimeter wave test device and the smartphone form factor. If you could just tell us a little bit about that, Matt.
Sure. Yeah. Sorry about that. Yeah. I think from the get-go, Qualcomm has been focused on mobilizing millimeter wave, and some increased challenges. I think the other spokesperson talked a little bit about some of the challenges that you get with mobile versus fixed, but it's both challenges from maintaining the link with a mobile device moving around, but also form factor constraints. And when you're talking about fixed, you got something that's plugged in that's traditionally not moving, and so with mobile millimeter wave, you also have to overcome the challenges of getting something that's power, cost, and form factor optimized. And so last Mobile World Congress, we showcased our prototype system in real world mobile environments, both indoor, outdoor, including drive tests that exceed 30 miles per hour. I think what you'll see with 5G and coming in, starting to be commercialized in 2019, is that the technology enables both this fast beam switching and steering to maintain that mobile link, and then advanced antenna technologies that we're integrating into the device allow the device to connect to those beams without driving up the cost and power and size of these form factors to a point where it's not mobile anymore. And so, yeah, we've seen very promising results in being able to both maintain and sustain broadband communications in both indoor and outdoor environments, mobile environments.
And Ken, this is something that you and Matt both touched on in your presentations, and I was hoping maybe you could explore the topic a little more. But in order to provide a continuity of service as someone moves throughout a network, once 5G is commercialized in limited hotspot type areas, do you think that we'll see, or I guess a better way to say that is, how do you think carriers will balance their CapEx spending in terms of putting 5G out there commercially available while still investing in Gigabit LTE to provide that umbrella of service continuity?
Iterative baby steps that then start getting bolder and bolder as time goes on. It depends on the availability of devices, the adoption rates by the customers of the service providers. We're starting we're going to work to build a virtuous cycle, but we start with a clean slate. So we'll begin with 5G in some limited areas. Some of the future forward device suppliers will bring out a limited number of offers. Early adopters will give this a try. word of mouth spreads, the operator then expands the area, more devices come into the market, the area expands again, and just over time it will grow. It's one of the beauties of 5G is with multi-connectivity, complemented by Gigabit LTE. The user experience is not a harsh shift back and forth. It's designed from the get-go to accommodate both of these environments, and Gigabit LTE from a perception point of view brings a lot of what the end users are going to be able to perceive and be expecting.
And Ken, one more question. You had mentioned the potential for Gigabit LTE to enable some new and interesting enterprise use cases. Can you expand on that a little bit?
Yes, so I mean, I gave an example of being able to transfer video files from the field if you're a television reporter, but I think the augmented reality is also very interesting. We end up with more, a richer set of information that can be exchanged, transmitted on the downlink to the end user. I think the big change will probably be in business processes that allow more enterprises to take advantage of capabilities moving into the cloud and having mobile field forces in a position to leverage that thanks to the speed of the Gigabit LTE.
Ian, we have an audience member that's asking for some clarification around millimeter wave. Specifically, he asks, researchers are spending a lot of time talking about millimeter waves as a way to solve the spectrum crisis. Why are millimeter waves more important than spectrum sharing that you see with LAA, LTEU, and then CBRS?
I think it's just predominantly, gross bandwidth. The 11 gigahertz of bandwidth that the FCC released is multiple times the amount of bandwidth available in the existing bands. So all things being equal, increased bandwidth helps increase data rates. Now there's problems that go with that, but it's simply we have congested spectrum below 6 gigahertz, and there's very, very nice technology developments being done in carrier aggregation and increasing the bits per second per hertz, but just the gross amount of available bandwidth in millimeter wave just helps increase data rate through brute force technique.
And Ian, one more question. I've seen this at a few trade shows, but I believe Anokiwave at Mobile World Congress has a 256 element active antenna that you're going to be demonstrating. Can you just tell us a little bit more about that active antenna array and how your industry partners are using it? I know you did some work with National Instruments that tapped that instrument. If you could expand on that. So
we actually have, I think, two 256 element antennas of our own at Mobile World Congress, but customers will also be either demonstrating or displaying privately or non-privately their own arrays, which have been built using our technology. Our antennas were developed as really demonstration vehicles for two reasons. One, to show the kind of performance that can be achieved with our support and behind the aperture electronics. We're a semiconductor company, not an array company, ultimately. But it also gives test and measurement companies the ability to have something that they can use as a platform vehicle for demonstrating their capabilities for over-the-air measurement or over-the-air data transfer. Specifically, National Instruments have a baseband box that can do full gigabit per second support through over-the-air links to a receiver, and they need a partner for demonstration of the active antenna technology. And our antennas are really plug-and-play vehicles to allow somebody to get up and start steering beams and look at channel sounding and over-the-air data links very, very quickly without having to invent their own air interface. But there will be other solutions at Mobile World Congress too, and obviously they're not necessarily going to be including our badge on the front of the antenna.
Right. Thank you, Ian. And Kasshif, this is something that you and I have discussed and something that's addressed in a little more detail in the report that accompanies this webinar. But I was hoping you could touch on, in addition to this move to Gigabit LTE, we're seeing a concurrent transition from physical to hybrid to virtualized networks. So as operators go through that transition with a mix of physical and virtual probes, how do they maintain a real-time look at their network metrics?
Yes, Sean. So basically, I mean, as we virtualize network, right, you have these point solutions that they're using today in that network. And of course, as we go through the virtualization exercise and the scale of the network changes, then the visibility into the network that needs to change as well. Otherwise, it won't be scalable. Because when you're talking about small cells getting integrated, I mean, higher throughput, I mean, demands that we are seeing. So if, let's say today, if a service provider has, let's say, one technician or one RF technician for about, let's say, 50, 60 cell sites, now you're talking about with the small cell additions and DAS and what have you, it will be it will be significantly large. Now, in that case, to manage a network of that size, you will have to look at solutions from an assurance perspective, which can scale too. So that's where, I mean, we as Viavi also are working on a solution called Nitro, which is our network integrated test and real-time measurement solution, basically. And it will actually help you to use your current solutions, as well as it will help you with virtual agents and virtual probes, which can collect the data from different network nodes, from node Bs, CPEs, what have you, and build a complete picture, perform an analysis for you, identify the problems and what have you, and then you can look at your problem areas and whatnot. So the idea is getting an end-to-end visibility across a much larger network with recommendations and results as we go through that whole exercise of going from physical networks to hybrid networks and to completely virtual networks that we expect in the future.
Right. Thank you, Kasshif. And I think we have time for one more question here. Matt or Ian, I think either one of you could answer that. But essentially, Franco is asking about the propagation effects of millimeter wave for changing conditions like weather, foliage, building materials. What are you all hearing from your ecosystem partners that are in the field testing these products?
So go ahead, Matt, if you like.
Sure. Yeah. I mean, we've done extensive testing ourselves. You know, as I was saying, indoor, outdoor, across different construction materials, the effects of rain, effects of foliage. I think in general, what we found, and there's lots of detailed information on that testing on our website, is that we've been pleasantly surprised at the ability to maintain a robust link with millimeter wave. There's always going to be coverage gaps with millimeter wave, and that's a main reason why the design for 5G for mobile millimeter wave always has an anchor in the lower band technologies, whether that's 5G NR or utilizing Gigabit LTE. So there's always that anchor from a control and system acquisition, and so there's that seamless switch if a coverage gap exists. But we've actually been very pleasantly surprised by you know, the performance of millimeter wave. I think one thing that we found for mobile millimeter wave specifically is that it will primarily be an outdoor to outdoor solution or an indoor to indoor solution. An outdoor to in is not really feasible for mobile millimeter wave deployments. But the net effect is if you deploy outdoor millimeter wave and you free up a lot of capacity for the lower bands by doing that, you're then freeing up those lower bands to service the indoor users.
Ian, do you have anything you'd like to add to that?
No, I think that was a perfect summary. That's you know, very much in accordance with the feedback and information we've been getting from our customers. You know, if you take, for example, rainfall was mentioned. For the kind of propagation distances at millimeter wave that are typically being talked about, which is, you know, a few hundred meters to maybe a kilometer, even at 28 gigahertz, severe rainfall only adds it's in the 2-3 dB kind of increase in propagation loss as a flat fade. So it can be handled, as Matt said, with pleasantly surprising results for the most part. Indoor to outdoor is obviously a bigger challenge, but again, Matt outlined the restrictions and the solutions there perfectly.
All right, excellent. Well, we've reached the end of our allotted time, so I'd like to thank all of our panelists for their presentation and for their participation in the Q&A, and I'd also like to thank all of the viewers that joined us for this session. Reminder that the presentation will be made available following the close here, and that we've got a report that takes a deeper look at this topic coming out in the next few days. So thank you again for joining us.
Thank you all.